relationships, creating and graphing a table of values. When we have a formula to represent a relationship, we can use a table of values to create a set of ordered pairs that can be plotted on the Cartesian plane to represent the relationship. First thing I have to realize is I need to create a table of values, and then I need to choose values for the independent variable for x. So I might choose -2, -1, 0, 1, and 2. The next thing I have to do is take these x values and I'm going to substitute them in to solve for the y. And of course I have to follow the guidelines of my good friend BEDMAS. Now if I look at this if I look at this formula here, y equals 2x plus 1, if I want to create a table of values and graph the relationship represented by that formula, first thing I need to do is choose my x values. Generally, if I'm given an equation, if I haven't been given any restrictions or information that tells me I can't have negative values, I would just pick some nice values like -2, -1, 0, 1, and 2, like you saw in the table before. Then it tells me I need to substitute in to solve for y. So whenever I substitute in, we're going to put brackets for the variable, and then the next thing I do is I put the value in, which in this case was -2, and it's 2 times -2, which is -4 plus 1. I'm going to just clean that up a bit. That's not very neat. So we'll do that again. Y equals 2 times -2 plus 1. And that's -4 plus 1. And -4 plus 1, I have more negatives than positives, so I'm going to subtract them and keep the sign on the larger number, which is the negative, so it's -3. And my ordered pair will become -2, -3. The next one, y equals 2 times -1 goes in the brackets, plus 1. So I've got -2 plus 1, and -2 plus 1. I have one more negative than positives, so the ordered pair is -1 for the x value and -1 for y. Y equals 2 times, I'm going to put brackets there, and then I'm going to take my independent variable value, which is 0, and substitute it in. And of course, 2 times 0 is 0 plus 1, so y is 1. And the ordered pair is 0 for x and 1 for y. Then y equals, again, I've got 2 times something plus 1. 2 times the independent variable, which we use the value of 1. 2 times 1 is 2 plus 1. And 2 plus 1 is 3. So the ordered pair is 1 for the x value and 3 for y. Finally, our fifth point, y equals 2 times 2 plus 1. And 2 times 2 is 4. And the ordered pair would become 2 for the x-coordinate and 5 for the y-coordinate. The next thing we need to do is plot those, because we wanted to plot the relation. So the point -2, -3, it tells me to start at the origin, -2 horizontally, because that's my x first, and then I go down 3 and plot the point. -1, 1, again, start at the origin. I'm going left 1, down 1. Start at the origin. For 0, 1, I'm not moving left and right, and I move up 1. 1, 3, 1 tells me to move right 1 because I'm going in a positive direction, and 3 tells me go up 3 because I'm moving again in a positive direction. 2, 5, start at 0, 2 to the right because that's positive, and up 5 because that is also positive. If I look at those ordered pairs, they appear to have an increasing positive relationship. It looks like it's a strong correlation. And in fact, if I try and draw a line through my ordered pairs, I will see that I really have a perfect positive correlation. which doesn't happen very often. And these are a special type of relation that we're going to study in Unit 2 and Unit 3. They're called linear relations. Okay, and if we were to draw a line of best fit, we would always see that for a linear relation, it's going to go through all of the points. Now, before you come to class tomorrow, try page 13, 1A and B.